Today we will see how to enter the program in 8085 processor and execute the program using ALS kit. Now let us take an example of addition of two 8-bit numbers. The program is as follows. As you can see here, we start from the memory address 8000. At 8000 the instruction is LXIH 8050. Now it is a 3-byte instruction. As you can see, LXIH is the instruction, 8050 is 16-bit address. Hence, it is a 3-byte instruction. At 8000, we will be entering the code of LXIH. At 8001, we write the address, the lower byte of the address, that is 50. At 02 location 8002, we write the higher order address of the address bit, 16-bit address bit, that is 80. At the next location, we will be moving the contents of the memory location to the accumulator, move A comma M, the code corresponding to move A comma M. At 8004, we select the next data from the location 8051. Now before adding the two numbers, we want to initialize the carry flag. So carry flag is initialized at 0 by using the instruction MVIC 00. So after initializing the carry flag, we perform the addition of the two numbers stored at the location 8050 and 8051. When once the addition is performed, addition will always store the result in the accumulator, and the effect of the result will be shown by the flags. So whenever the result generates the carry, we want to increment the carry flag, that is the C register. So that is why we are using the loop jump on no carry to the display. So this is where the display is referenced, that is 800C is the address where we have given the label display. So whenever the carry is not generated, it will come to the location 800C and display the result. Whenever carry is generated, then C is to be incremented. So we use the instruction INRC. INRC will increment the carry flag. So whenever the result after adding the two numbers, whenever there is a carry that is generated, that is referenced by the INRC instruction. Move M comma A, move M comma C will display the result at the two consecutive locations along with the carry flag. Whenever carry is not generated, it is not taken. Let us try to write the codes corresponding to the instructions. So when we look at the opcode sheet, LXIH, as you can see here, has the code 21. LXIH has the code 21. So corresponding to that, we will be entering the code 21. So this will be 215080. So the data entered will be 21. At 8000, the code will be 21 corresponding to LXIH. The lower order address is 50. The higher order address is 80. That is how we will be entering the data 215080. From the code move A comma M, as you can see here, move A comma M is 7E. So at the location 03, we enter the code 7E, which corresponds to move A comma M. INXH has the code 23. It is according to the alphabetical order. You can see that INXH is 23. So we will be using that 23 corresponding to INXH. Next, MVIC. MVIC is 0E. So this is a 0E. Next, location it will be 00. So 0E is the code of MVIC. Similarly, add M is given by 8E. JNC is given by the code D2, and the display is at referenced address 800C. Therefore 0C is the lower byte and 80 is the higher byte. So it is a 3-byte address, 3-byte instruction. INRC is referenced at 0C. The code corresponding to that is 0C. INXH is 23. Move M, A is 777. INXH is again 23. Move M, C is 71. We will be using either CF or EF as the instruction corresponding to the two kits that we'll be using. We use the ALS kit. So first, reset. So as soon as you press the reset button, you get a sign on message. So sign on message is SDA85. We start from the memory location 8000. So for that we use substitute memory. So whenever substitute memory button is pressed, you can see that the display will be off, indicating the data field and the address field, because we will be starting at the address 8000. So we specify the address as 8000. So whenever 8000 is pressed, you can see that the data field is empty. Use the increment or the next. So in this case, next button. So whenever next is pressed, the data field will be active. So enter the code. The code corresponding to that will be 2150. So we'll be entering 21. Next. Press next. So it will go to the increment to the 8001 address. There we will be entering the address 50. Next, address 80. Next, 7E. Next, 23. Next, 0E. Next, 00. Next, 8E. Next, D2. Next, 0C. Next, 80. Next, 0C. 23. Next is 77. Next is 23. Next is 71. Next is CF. So we'll check once again. Reset. Substitute memory 8000. Next 21 50 80 7E 23 0E 00 8E D2 0C 80 0C 2377 2371 CF. So we have entered the program now. Now we want to enter the data at the locations 8050. We want to give one data. So let us take 20 is the data that is given at 8050. At 51 I will be giving another data that is 30. So the result of these two should be available at 52 and 53. At 52 I should get the result as 50. At 53 I should get the result as 00. So this is my sum. This is the carry component. So these are the two numbers that we have taken, A and B. So the sum of these two will be available here and the carry will be available here. So we have entered the program now. I want to enter the data. To enter the data, again reset, substitute memory 8050, because we need to enter the data at location 8050, 8051, 8051. Therefore 8050 we have given. Next, the data is to be entered. 20 is the data that we have entered. Next location 30 is the data that we want to enter. So we have entered the data, we have entered the program. Now we want to run the program. To run the program, the procedure is reset, go, starting address of the program, that is 8000, then execute. So when once you get the sign on message, the program is executed and it is proper. Now let us check the result. The result is at the memory location. Therefore, substitute memory 8050. We have given the data as 20 and 30. The result should be 50 and the carry is not generated. You can see that 20 plus 30 will be 50 and there is no carry that is generated. So this is how the program is to be executed. Once again, I will be revising the procedure. Reset, substitute memory, starting address of the program, keep on enter the code, whatever the code that is to be entered corresponding to the instruction, all the codes are to be entered till the last instruction, that is the restart instruction, RST1 or RST5. So we have entered the codes till we get CF in this kit. So 8010 is the last. You can see that 8010 is the last instruction at which CF is entered. Afterwards, we need to again go to the next location so that CF will be stored in the memory location. Next, we need to enter the data. Again, substitute memory 8050, give the data. Let us consider I have given 22 and 55 are the two data that are given. Then reset, go, starting address of the program 8000, execute, substitute memory 8050, we have given 2255, the result is 77 and there is no carry that is generated. Okay,